So, do you guys all have this printed out? Okay. Okay, so if you pull it up on your laptop, I would suggest pulling up, it says Matt's Intro to C session. He's another person. You could just like Control F and then type Matt, and you can see this packet, and it might be the updated packet, if you guys would like to see it. Otherwise, I will stream just these. Awesome. So do you guys all have like the beginning of this packet in some capacity, like you see this table of contents? In some, are we all okay on this? Yeah. Awesome. So are we streaming right now, by the way? Okay, cool. Awesome. So yeah, as you guys saw at the beginning, we won't be able to do things on my laptop, so I would have liked to be able to compile code and show you guys that the code that we write here works, but we'll probably just do some pencil coding in and make do with what we got. Awesome. So to begin, are you guys all, can you see this page? If you actually don't have it with you, it's not too much of an issue unless you want to be able to take notes on it. I'll solve them all up here so you can see it being done in real time. So yes, to start, we are going to start with some code tracing. So you guys have probably seen a bunch of questions like these on exams before. Awesome. So in the beginning, it just asks, what is the output of the following segment of code? And then we see a printf statement down there, so the goal of this problem is to just get the output of the code, right? And there's a bunch of arithmetic statements changing these two values. So here we have A, here we have B. So we want to know what A and B are. So in general with these problems, what I like to do is make a little table over here to the side. Always feel free to let me know, by the way, if you can't see. The projector is behind me, so if I forget to like move up and down, whatever, feel free to let me know. So I'll generally just start with what it is. So we have A is equal to 5, and then B is equal to 9. So A equals 5, not A. A will be equal to 5, and then B will be equal to 9. And then we see this arithmetic operation, B plus 15 times 2. So B is equal to 9, so you could sort of in your head replace this with a 9. So we have a plus and a multiply. Which one comes first? The multiply, right? So first thing we do is 15 times 2. So what's 15 times 2? 30, and then 30 plus the value of B, which is 9, 39, right? And then that gets assigned to A, so A is now 39, right? So then we have B plus equals A minus 6 over 3. So first things first, the value of A is 39, so you can sort of replace this value A with a 39. The other thing is you have a plus equals. It's an arithmetic operation, assignment in the same statement. So what does that do to the right-hand side over here? What do I have to do? This seems a little bright. Can I like turn the brightness down? Is this a little easier to see? Is this better? Why does it look so like, here, let's try this. Does this look better? Any better? No? Awesome. Well, I can't make the projector do what to do. Apparently the projectors in these rooms are not good. Awesome. So we have this line right here. We have A minus 6 divided by 3, and it's a plus equals on for the assignment. What does that mean? What are we going to add over here on the right side? The value of B, right? Which is currently what? 9. So I'll just put a little plus 9 over here. It would be right here, but I don't have enough space. And addition is commutative, associative, so we don't really have to worry about that. So first things first, we have a minus, a division, and a plus. Order of operations tells us which one comes first. The division. So first thing we do is 6 divided by 3, which is equal to 2. So this becomes a 2. And then you have 39 minus 2 plus 9. So what's 39 minus 2? 37, and plus 9 is 46, yeah. Yeah, 46. So we just have this 46 here. So we're good for that line. And then we have another plus equals A plus B down here. So A, the current value of A is 39. The value of B is 46. So it's a plus equals, so what does that mean we must do? Yes, which is what value? 39, yeah. So we have 39 and 39, value of that. I don't want to waste, like, you guys, yeah, and then plus 46. What is that? Yes, 124. So then we're left with 124 for the value of A. And then we see B++. What does that do to B? Adds 1 to B. So B becomes 47. And then we hit the printf line. So the last values that they were is A is equal to this, and B is equal to this. So that means that the value A will print as 124, and the value B will print as 47. And here you can see that the answer to that question is C. Does that make sense? Are we good on that question? Any questions on that? Awesome. Relatively straightforward. So let's move on to a little more code tracing. So we have x equals 12, y equals 4, and z equals 7. So I'll just put x, y, and z over here, and we can just maintain a very similar table. This is just how I myself, when I took Intro to C exams, this is how I saw these problems. These problems are all over like every single Intro to C exam ever. So you sort of want to develop a technique of just being able to solve them really quickly without having to think too much. So the first thing we do is we check, is x greater than 2 times z? So what's 2 times z? This is 12, 4, and 7. 2 times 7? 14. And the value of x is 12. Is 12 greater than 14? No, this will not run. So then we have else if y times 2 greater than 6. So what's the value of y? 4. And 2 times 4 is 8. Is 8 greater than 6? Yes. So this will run. That being said, will we ever, since this is going to run, this is else if, is any of the code in else gonna run at all? Do we even need to look at that code? No, because else if statement. Awesome. So we have plus equals 15 times 2. So it's, since it's x plus equals, what does that mean we have to add over here? Yeah, perfect. So then we have 15 times 2 plus 12. So first, the times with the plus. Times, right? Then we have 15 times 2. What's 15 times 2? 30. And then 30 plus 12 is 42. So this is equal to 42. So then the value of x is equal to now 42. Awesome. So then we have y equals x plus z times 2 divided by 7. So the value of x currently is 42. The value of z currently is 7. And then we have 2 divided by 7. So we have this z times 2 divided by 7. What's going to happen first, the times or the division? The multiplication, because it comes first, right? Awesome. So what is 7 times 2? That's 14, so we can put like a 14 here. And then we have 14 divided by 7 is equal to 2. And then add 2 to 42. Becomes 44, right? So then we have y is equal to 44. Perfect. So then z plus equals x mod y. Awesome. So the value of x is currently 42. The value of y is currently 44. So do you guys know how the modulus operator works? What does the modulus operator compute? Yes, the remainder, right? So the modulus operator asks the question, okay, what's 42 divided by 44? And I think a better way to rephrase that is how many times does 44 go into 42? How many times does 44 go into 42? 0 times, right? And then what's left over? Yeah, so it's 0, remainder 40, right? See, if it goes in 0 times, we have 42 integers up to the number 42 from 0 to 42, right? So the value left over is 42. So then it's this plus equals. So this whole thing is equal to 42, this x mod y. And then it's z plus equals. The current value of z is equal to 7. So we add 7 because it's plus equals. What's 42 plus 7? 49. Perfect. Don't have to worry about this else statement, and then we hit this printf statement. So these are our last values that we have. We are left to the screen. Okay. Awesome. So let's move on. Some more code tracing. There's a wire in front of the thing. Awesome. Perfect. So what is the output of the following segment of code again. So we have A equals 7, B, and C. So then we have A mod 6. We can go ahead and write our table again, B, C. So we can do this. So we have A is equal to 7, and B and C don't start with anything, right? So in general, I'll probably just not put it in the table quite yet. Do you guys know what is currently inside of B and C? What kind of value? Not an address. So when you don't initialize a value, it gets some sort of garbage value. So it's some random gigantic number. Not very useful to you, but yeah. So right now we have A mod 6 plus 5. So A is currently 7. So we have 7 mod 6 plus 5. So again, the modulus operator asks the question, how many times does 6 go into 7? 1. Now what's left over? 1, right? So 7 mod 6 comes out to 1. So then we have 1 plus 5. What's 1 plus 5? 6. So 6 gets assigned to B. B is now 6. Awesome. So for C, we have B times A divided by B mod A. So this is in parentheses, so this happened first. So what is B currently? It's 6. A is currently 7. So we have 6 mod 7. Asks the question, how many times does 7 go into 6? 0 times, and 6 is left over. So this whole modulus operator evaluates to just 6. So then we have B times A divided by 6. So what's the current value of B? 6. And then we have A is equal to 7, right? So we have 6 times 7 divided by 6. So what's going to happen first, the multiplication or the division? Multiplication. So what's 6 times 7? 42, and then divided by 6 is 7, right? So yes, what was this assigned to? This was assigned to C, so C will be equal to 7. So now we have one more. We have a divided equals. So this is the same as before. This is the same thing as writing A equals A divided by, in parentheses, C mod B. So first thing, this is just like A divided by this. So what is C mod B? C is currently 7. B is currently 6. So how many times does 6 go into 7? Once. And then what's left over? 1. So C mod B is equal to 1. And then we have A divided by 1. A is currently 7. What's 7 divided by 1? Yes. Yes, it is 7. So what is the value of A going to be? Just 7, right? So then pay close attention to this printf statement. It has these, it has %d, %d, %d. Do you guys notice the order of this is not ABC? So it's a trick. This is something to pay attention to when you guys see these things. Just because it's ABC and it's alphabetically doesn't mean that inside of this printf statement that they're going to come in that order. So that being said, B is this, A is this, and C is this. So what's going to print? B comes first. So we get a 6, and then 7, 7. They're both 7, so it doesn't matter too much. Yes, so that is what we'll print to the screen. Are we okay with this one? Awesome, perfect. Moving on. So then what is the output of the following segment of code? Hint, there may be more output lines than necessary. So now we have a nested for loop. So let's start with this. We have I and j, and then we start at I equals 0. Is 0 less than 3? 0 is less than 3. So that means we get to do the code associated with this current for loop. So then we have j starts at I, right? So if j starts at I, j currently is starting at what? 0. So j is equal to 0 at first. And then we have j less than 4, j plus plus. So is 0 less than 4? Yes, it is. So we get to go inside of this loop. Then we print I plus j. Remember, I was equal to 0. What's j equal to? 0. So we have 0 plus 0, right? And we're going to print that. So the output of line 1 is just 0, right? We're not done yet, though, because we check, is j equal to 3 currently? No, it's not equal to 3. And then otherwise, we print a space, right? So there will just be one single space right here. Awesome. So then what's the very next thing that happens in this code? We increment j, right? So j goes up by 1. J is now 1. And then we check, is 1 less than 4? Yes, so then we print I plus j again. What was I? It's still 0, right? We never incremented I. So then we just have 1 plus 0, which is equal to 1. What's up?
So wait, it doesn't go back to the I?
Good question. So do you see that this for loop is not done running yet? So we can't ever go back to that initial for loop. All of the code, like if I were to put brackets here, right? All of the code inside of those brackets must finish execution before we ever go back to the incrementing of I in the outer for loop. And since what happens to be inside of this for loop is another for loop, that whole for loop has to complete before we can ever get back to incrementing I. That makes sense? Perfect. So yes, so now we add j was 1 and I is still 0, so what happens here? 0 plus 1. Prints a 1, and j is not equal to 3, so we just print another space, right? And we increment j again. What is j now? 2. So we check, is 2 less than 4? Yes, 2 is less than 4. So then we print 2, which is j, plus I, which is 0, so we just get 2. And then j is not equal to 3, so then we print another space. And then we have j plus plus, so j is now equal to what? 3. Is 3 less than 4? Yes, so then we print 3 plus 0, which is just 3. Is j equal to 3? Yes, so then we print a new line, right? So now we would enter output line 2 in this little drawing that we have here. So then j plus plus, j is now equal to 4, right? We had a 3 and we had a 4. J is now equal to 4. Is 4 less than 4? No, 4 is not less than 4. So then we break out of this loop. Now where do we go? Back to the I. So now I is what? 1. I is 1. So now I is 1, and go over here and make a separate table. And then now we're going to go back to j. So where does j start now? Starts at 1, right? So then we start. J is equal to 1. Is 1 less than 4? Yes, so we get to go into the loop. Then we print off the statement, 1 plus 1, which is 2, right? And then j is not currently equal to 3, so we just print a space. Then j gets incremented. J is now 2. Is 2 less than 4? 2 is less than 4. So then we have 2. What's the value of I right now? 1, right? So j is currently 2. So we just do 2 plus 1, right, which is equal to 3. Perfect. And then j is not currently equal to 3, so then we just print another space. And then j gets incremented. J is now 3. So now we do 3 plus what? 3 plus 1, which is equal to 4. Perfect. And then j is not equal to 3, so we print another space. Then we do j plus plus. So j is now equal to 4. So is 4 less than 4? No, it's not, so we break out of this loop. Perfect. Now we increment I again. So here's I. What's the value of I now? 2. So we have 2. Is 2 less than 3? That's perfect. So then j starts at 2. Is 2 less than 4? 2 is less than 4. So we do 2 plus 2, which is what? 4. So then we print 4. Perfect. So j currently is at 3? Is it equal to 3? Now it's 3, right? So we printed a space. So is 3 less than 4? Yes. So then here we do 3 plus 4, which is equal to 3 plus 2, my bad, which is equal to 5. And then j was equal to 3, right? So now we just print a new line. So we print a new line. I gets incremented. What is I now? I is now 3. Is 3 less than 3? Then we're done. Does that make sense? So this is how this is printed. So this seemed really monotonous to any of you guys? We're going all of these. Yeah, so here's what I would suggest. First off, I would suggest being very meticulous about how you go these problems. You guys have probably seen a bunch of problems like these before, probably like on exam 1, or probably whenever you guys learned loops, you saw an exam like I would trace through, especially when you see nested for loops like this, very, very slowly. And because I would trace through them very slowly, I might, as an Intro to C student, as I'm traversing through my test, when I see this, might say, oh, I know that this is going to take me a little bit of time. I'm just going to skip this and go find a question that I can finish and then come back to this, right? Because this is just one multiple choice question. You want to get as many points as possible. So I would maybe come back to this question a little later. Are we okay on this? Yeah? So Next thing we have is what is the output of the following segment of code? This is a very interesting one. This looks like a nightmare, doesn't it? All of these arithmetic operators. So let's check this out, see what's going on here. I is equal to 25. I is 25. And then we have A equal to 7, B equal to 13, and C equal to 12. So we have I mod 10, which is 25 mod 10. And the first thing we do is a loop, so we check to see if the statement is true. So what's 25 mod 10? 10 goes into 25 how many times? Twice, and what's left over? 5. So is 5 equal to 0? No, it's not. So we don't do any of this. Big trick, right? So then what gets printed? We have A, B, and C. What's the value of A? 7. What's the value of B? 13. What's the value of C? 12. Look at that. Nice and easy. Right? So not as much of a nightmare as you think. Just make sure that you always go into your loop before you start doing all of this unnecessary computation. You might end up in a situation where you lose a lot of time and you shouldn't have computed any of this anyway. So yeah, don't do that. Then we get asked this question. What is the difference between a while loop and a do while loop? Can you guys tell me the answer to this question?
I know do while loop does it at least once.
Yeah.
Before it
Yeah, that's the main difference, right? So in a do while loop, you're always guaranteed to execute at least one time. In a while loop, is that always necessarily true? No, and we see that with the above loop, right? So if I had made this a do while loop, right, if I did not have this statement here, and instead I put a do, and then down here, while I mod 10 is equal to 0, then now this would execute one time, and you have to do that nightmare of a calculation. But that's not there, so we don't have to do that calculation. I don't want to do it anyway, because we want to get through this whole packet. Awesome. Pass by value. So this is the point in the session where I would really like my laptop, because it's not that I don't like pencil coding, but it takes a long time because I can type a lot faster than I can write, and also my handwriting is horrendous. So bear with me. It would be a lot nicer if I had a nice computer that I could type. Guys, awesome. So the first thing that we see is write a function prototype for a function named findArea that returns an integer and has two integers named width and height as parameters. Perfect. So for function prototypes, it's called findArea. So what do we at least know that we're going to have to write? Int findArea. Why int in front of it? Because it returns an integer, right? And then what's this very first thing? This very first parameter? Int width. And then we have what? Int height. And then it's a function prototype. So do I implement this function prototype? Just write the function prototype? No, I do not, right? So what do I have to put here? Semicolon, perfect. So given the function prototype above, fill the function so that it's square with dimensions height and width. Okay, perfect. So brackets here assume that this is the top of our function. I don't want to rewrite that. I wish there was a copy and paste when I'm writing, but there is not. So how would you guys implement this function? What's your idea? I think one of me and the other Intro to C tutor, Intro to C Sarc tutor, wrote a lot of this packet together. And it's interesting. I didn't write this question, but he put square here and dimensions width and height. So for a square, what's the width and height? Do you agree that they're the same?
Yeah.
So do we need to pass in two things if it was a square? No, we don't, right? We only need to pass in one side and then multiply them together, right? So let's do this. It's not a square. It's a rectangle. You could potentially keep it a square, but that's a little bit of a waste of time. And that's also assuming that if you're passing in a width and a height, that the user knows, not the user, the programmer knows who's using this function, that it's a square, so you have to pass in the same thing. Awesome, so how am I going to compute so what's the area of a rectangle? Back to FCAT, if you ever took it. Width times height, right? So could do something like this. Do you guys agree? I could do something like int area equals width times height, semicolon, and then return the area. I could do something like that. Is there a simpler way to write this function? Yeah, right? So we could just suppose these are two separate things. We could just return width times height. And now it's a one-line function. Does that make sense? So the width and the height are passed in, right? So there's no reason, since we're just computing the width times the height, there's no reason to get this intermediary variable and waste space, like come up with 32 bits to represent this integer, and then multiply them together and then return 32 bits to do that, right? We could just return the result of multiplying those two numbers together. Does that make sense? Awesome. Are we okay here? Some of these get really big. It's going to be really annoying for me to pencil code all of them. And you guys have to look at my awful handwriting. Awesome. So this is an interesting one. We have what is the output of the following line of code. Then we have x, y, and z. So this is like code tracing, except now we have some functions that exist. Interesting. X equals 12. Do this. And then we have y is equal to 15. And then z is equal to a garbage value currently. So then we have mult y and 3. What is this mult function? So we have a comment that tells us exactly what it does. So we're assuming that this was implemented somewhere else in the code. And mult just returns a times b. So y is currently equal to 15, right? So we have 15 times 3. What's 15 times 3? Yes. It is equal to 45. So then this evaluates to 45. And you guys agree that when we see this function, that we will to where this function is, compute that, and we will not be in main while we're in that function. We are entirely in that function, and all of these variables don't really have anything to do with what's going on up there. Awesome. So we have 45, and then once this function returns, that gets assigned to z. So z is now equal to 45. So a big question, I think one of the reasons, I didn't write this question either, I think Matt wrote it. One of the reasons I think he did this was he wanted to highlight the fact that y did not change, right? Y we passed it into this function, but y did not change as a variable. It's currently 15. I think that was his idea when he wrote this question. So then we have pow1, 2, and then we have this comment that tells us that pow ab returns a to the power of b. So we have 1 to the power of 2, so that's 1 squared. What is 1 squared? 1. So this is equal to 1, so x is now 1. So then we have z plus equals y to the power of 1. What is y currently? 15. So we have 15 to the power of 1. And then that's 15 plus x, which is currently 1. And that's equal to 16. But this is a plus equals, right? Always look out for these plus equals. They can hide away from you. So this is 45 plus 15 to the power of 1 plus 1, which is 16. So what's 16 and 45? 61. So we get 61, and that's assigned to z. So here we have 61, and then we print off all three things. So we can just circle all of these, and then what will get printed to the screen, it will be 1, 15, and 61. Are we okay with that? Awesome. So the next thing, man, I actually had a lot more code for you guys. What I wanted to do was introduce a few more ideas here, but we don't have enough room since I'm going to be pencil coding this all in. I wish I had my computer to type out more for you guys and show you guys that the code works. So this says, write a function that receives an integer array and an integer representing the size of the array and returns an integer that holds the largest value in that array. So it's not as difficult as you think. All you're doing is looking for the maximum value within an array. And then we want to return that maximum value. So if we're going to return the maximum value in an integer array, what does the return type need to be for this function? An integer, right? So the return type is integer. Didn't specify a name, so we're just going to call this largest value. You think that's okay? So then we're going to pass two things into this array. So not this array, this function. So we're going to pass in the array, and we're going to pass in the size of the array. So I would like to highlight something. We're going to pass in an integer array. I'm going to go ahead and I'm going to call it a. So there's two ways that we can write this. When you guys first learned about arrays and functions, you guys probably wrote them like this, right? when you passed in an array to a function? What's another way that we can write this? This first parameter right here, do you guys know? A pointer, right? So you guys know that arrays are pointers, so we could write them just like this if we wanted to. Does that make sense? And this will still work just like a pointer does. So later when we get into pointers, we'll also talk about that a bit more. So then we have, the next thing that we pass in is the size of the array. So why don't we just put int. Because I know I'm going to be writing this, I would usually use more informative names than just a. I'm going to go ahead and call this length to keep it short so that I can write very, very little. Awesome. So for the largest value in the array, I think we're going to need several things. We're going to need, I'm going to call this variable, I'm going to call it max, because this is going to be the maximum value in the array. So, right? So I'll just say max. And what do you guys suppose I start max at? We're going to, well, I think it would be more informative to start it at some position in the array, right? Not the index, but maybe the first value of the array, right? So we could say something like max equals, if I want to access the first value in the array, what do I have to write? A sub 0. Awesome. So do you guys agree that this will get whatever the first value is and put it inside of max? I won't put a semicolon because I am pretty sure I'm going to need some more integers for now. Awesome. So if I want to find, what's your guys' idea? If I want to find the maximum value in the array, I'm going to need to go through everything in the array, right? So I'm going to need to check the first element, and then the second element, and then the third element. And at each point, I'm going to want to compare that element with the current max, right? So if I'm going to continually go and check the first thing and then the second thing, what sort of programming structure am I going to need? A loop, right? So let's go ahead and start that. So I have 4. I'm going to need some sort of index, right, which is why I didn't put the semicolon yet. So I'll go ahead and put I up here. So what do you guys suppose I start I? Do I start it at 0? It looks like I already sort of did, right? So I could just start I at 1. I already checked the first position, so I could start I at 1. You could start I at 0, but you would just do some extra you would check the same thing. You would say is max greater than max, and that would be a little bit of a waste of your time, right? Just saving one step of execution. So then what am I going to do for the condition? I is less than length, right? So len, and then just normal I++, right? Awesome. So at each iteration, what I'm going to want to do is I'm going to want to check, is the current max less than the current value in the array? Or alternatively, is the current value in the array greater than the max? And then if it is greater than the max, then the max is now equal to this element in the array. Does that make sense? So writing that in code, we see if I want to check is the element currently, I'll just put a because that's the name of the variable, is a sub I, this current thing, so in the first instance it would be a sub 1, is that greater than the current max value? If it is greater than the current max value, then assign this thing to the max value. Does that make sense? So at each iteration we'll check, is this current value greater than the max? Oh, it is greater than the max, so then set the max equal to this thing. Then you increment I, then you check, is this current greater than the max? Suppose it wasn't greater than the max. Then you won't enter that if statement, and you'll always be maintaining the maximum value. Is that okay? And then what's the last thing I want to do? What's the, let's see if we can find it. Returns an integer that holds the largest value in the array. So what should I do at the very bottom? Yeah, I'll return max. You guys agree that after that for loop, the max will hold the maximum value in the array? Does that make sense? Awesome. Any questions on this? Awesome. 936. Perfect. We are bombing through this thing. Page 6 of, I think, 13. Awesome. So now we have two-dimensional. So in main, this is a good one. In main, write a program that creates a 4x4 two-dimensional array and populates it with random values between 1 and 100. Good one. I like this one. So it says in main, so let's go ahead and do this. Int main, and then we'll do void here. Is the void required? No, it's not required. Good. Yes. So we have int main. So let's go ahead and do this. It says create a 4x4 two-dimensional array. All right, let's start there. Whenever you see these problems, start with the easy stuff, right? It just tells you to make something, so start with the thing. So we have int. I'm going to go ahead and call it a again. In general, when I'm doing my pencil code, I'll make my names very short so you guys get to see as less of my handwriting as possible. You can see my very squiggly, horrible attempt at an A. This is why I type for a living, by the way, because I can't draw things. So it's 4 by 4. So what do I have to do here? 4 and 4. Yes. So I'm going to leave this open because I'm pretty sure I'm going to need some more stuff. I won't close the semicolon yet. I didn't forget, I promise. So the next thing is we're going to populate it with random values between 1 and 100. So if we're going to use a random number generator, what should we probably use first? SRAND. We're going to want to seed our random number generator. If we don't seed it, what happens?
Then the program will compile and work.
Actually, it will. You can totally not seed the random number generator if you wanted. However, if you don't seed the random number generator, you get the same numbers every single time. If you're more interested in that, I won't go into too many of the details right now because we want to get through this packet. But go ahead and just Google why seed a random number generator in C. In general, Google is a programmer's best friend. So if you ever have little questions like that, you could just Google them. So yeah, if I want to seed the random number generator, what function do I have to use to seed? SRAND, right? Seed rand. So it's just SRAND, and then what am I going to pass in? Time null. N-U-L-L. Awesome. So time is a function. Null is a pointer. We'll get into that later. But time is a function. What time null will return, if you guys want some little bonus knowledge, it will return the time. It's, I think, what we call the epoch, which is January 1st, 1960 or 70. That's just been recorded, so if I'm wrong, I'm sorry. If you want to know what time that actually is, I don't have it committed to memory. Just Google what does time null return. Hopefully I was close, because that's going to go on YouTube. Fantastic. So the next thing we want to do, it says populate it with random values between 1 and 100. OK, so if I'm going to populate this two-dimensional array, what am I going to need? So visually, do you guys agree, if a two-dimensional array just looks like one row, what does, not a two-dimensional array, if a one-dimensional array is just one single row, how many rows is a 4 by 4 array, two-dimensional array? 4, and then there are 4 columns, right? So do you guys agree that for every element in the first row, I have to populate something, then I have to go to the second row and start back at 0 again and populate them, and then I have to go to the third row and populate them, and then I have to go to the fourth row and populate them. Do you guys agree that that's a thing? So if I want to, it seems like I have two sort of looping structures going on here, right? I'm starting at the first row, then I loop through the second row, and then I increment what the row is, and then I start again at 0, and then increment the second one. And then I increment what the row is, and then go to the third row, and then this starts at 0 again. So you might argue that we're starting, we start at row 0, right? So this is actually a good question. What are the valid indices for the rows right now? Is 4 a valid index for this array? Who says yes? So it's not, right? So we start at 0, right, in arrays? So if there are 4 elements in this array, then we have 0, 1, 2, 3 for our indices. Does that make sense? So 4 is out of bounds. It's too far. If we started at 1 in C, then we would have 1, 2, 3, 4. But we start at 0. If you ever program in MATLAB, it starts at 1, which will screw you up if you've been programming in a lot of other programming languages that start at 0 for a long time. So that being said, if we want to access the first element of A, if I'm looking in the rows, where do I want to start? At index 1 or 0? 0, right? I want to be at the first thing. So then I want to check a condition. What's the condition going to be? There's 4. Say again? I less than 4, right? So we check, is I less than 4? And then we're going to increment I. Perfect. So then we have another for loop, right? because now that's going to govern our rows. I want to be able to govern our columns now. So I'm going to have another index. I'm going to call it j, which is pretty standard. So I'm going to start that at 0. Also check, is j less than 4? And then increment j. Awesome. So since I have an I and a j here, I'm going to have to go up here and put an I and put a j. Perfect. So I want to access the ijth element. How do I do that in code right here? Here I have an A of this array. Yes. So the for loops do look slightly identical, right? Not slightly. They are identical, except for the fact that one has an I and one has there are no markers in here. And there's a whiteboard. That's helpful. Cool. So I would like to, I could draw a picture up here. So do you guys agree that this array looks like this, right? It looks like a 4 by 4 grid. 3, 1, 2, 3. So basically, here's what's going on. The columns down here, this will be our I. We have index 0, 1, 2, and 3, right? And then up here, the columns will be 0, 1, 2, and 3. So check this out. We want to start at 0, 0, right? And then we want to go to what next? 0, 1, 0, 2, and 0, 3. So do you guys see, this is j. It goes from 0 to 3. And do you see we start at 0, and we will go to j equals 0, j equals 1, j equals 2, j equals 3. Once j is equal to 3, j gets incremented to 4. Is 4 less than 4? No, so we do hit 0, 1, 2, and 3, and then do no extra things in that second loop. After the second loop runs, we increment j. J is, not j, we increment I, right? This loop breaks out. We increment I, and then I is now 1, which moves us down here. And then j starts at 0 again, and we can continue to populate these things, provided we write this line of code that is currently not here properly, right? So that being said, if I want to access this element in this two-dimensional array, how am I going to do it? ij, yeah. ij, and then we want to set it equal to a random number. First things first, do you guys understand right now that we are, at this moment in time, accessing what we want to, was that up there the entire time? I hope you guys were able to see that. Do you guys see that we're able to now, I will start at 0, and we will cover 0, 0, then j will get incremented, 0, 1, and you see I is not getting incremented for that first thing, and then we increment I, and then we do 1, 0, and then 1, 1, and then 1, 2. Is that all making sense so far? Awesome. So now we want to populate it with a random number that goes from 1 to 100. So if I want a random number, what do I have to use? Not srand. So srand seeds the random number generator. We have a function that will generate a random number in C. You guys know what it's called? Rand, yes, perfect. Rand. So we just have rand here. So rand will generate a potentially very large random number. It's just a huge random number. I want to restrict the range of this random number to, I want it to be from 1 to 100. Do you guys have any ideas on how we're going to do that? Yeah. So if I mod this by 100, say, that would give us the range. If I mod it by 100, if I take a large set of numbers, right, or I take any random number, it could be 4 billion. If I mod it by 100, what are the possible values that it could be? Not 1 to 99. What if it's divisible by 100? There's a remainder of 0, right? So 0 to 99, right? So do you guys agree that if I divide something by 100, then I won't have a remainder of 100? Because if I did, it would be divisible by 100. So you can have anything on the range from 0 to 99. So right now, if I just do mod 100, that will give us the range 0 to 99. I want 1 to 100. So if I take that entire set, right, 0 to 99, and increment whatever number I generate, right? So I have like, maybe I generate some huge number, and then rand mod 100 gives us the value 99. If I want that to become 100, what do I have to do? Add 1, right? So if I add 1 to this, then all of those values, 0, if the rand mod 100 gave us 0, if I add 1 to it, then I will have a 1. If rand mod 100 gave us 99 and I add 1 to it, I would get 100, right? Does that make sense? You might guess, well, Chris, why don't we just get rid of the +1 and mod by 101? What range does this give us? 0 to 100, and the directions said 1 to 100, right? So this would not work based on the directions. If it said give me the range 0 to 100, that would work, but it says give us 1 to 100, so we will mod by 100 and add 1. Perfect. So do you guys agree right now that this program creates a 4x4 two-dimensional array and populates it with random values between 1 and 100? Awesome. So if we were doing this on my laptop, we would also, I had vast plans to write up some other extra stuff that I don't think would take up too much time if we were typing. It would take too much time. I would like to print all of the values in the array and then print it to you on the screen, but I don't have a screen, and I don't want to write all of that because we need to get through the packet. So at the very end, we just return 0 because this is a main function, right? Is the return 0 required in the main function? No, but is it good practice to keep it there? Yeah, it is. Perfect. So here's an interesting question. Are you guys OK on this question, by the way? Yeah, so if you were to put this into a program, do you agree that there is no printf statement here? Yeah. So unfortunately, it would not print anything. It would populate it with random numbers, and then we would return 0 and then end the program. Maybe if we make it to the end, we can write some code somewhere else that will, like right here, what we would put right here, that would print all of the values. If we have some time at the end, we can go ahead and do that. Yes. So we'll see about that. But right now, this will not print anything. There's no print statements, so there will be no output to the screen. So this says, draw the boxes representing an array that contains the string hello. OK, so draw the boxes. This is, hopefully you don't get a question that I think is this unclear, like what is that? What this is asking, right, is draw basically like a pictorial representation of this string hello and what it looks like. And I think I have an idea of why this is pretty important, right? So we know we're going to have H, E, L, L, and O. I'm going to do this. I'm going to make some room. We have H, E, L, L, and O. So do you know how character literals are represented in C? How do we refer to a character literal in C? Single quotes, right? So I'm just going to, just to make sure that we know that these are characters, I'll put single quotes around them. So draw the boxes. Love this question. So H, E, L, L, and O. Is this the answer? Are we good now? No, we're not. What are we missing? The null terminating character, yes, is what it's called. So what does it look like? Is it this slash or this slash? The second one, yeah. So it's this, and this can also be a character literal. Just note, this array could be larger, right? So, and this is why we include the character literal. So suppose I have a character array. It has 500 elements in it, but it's only storing the string hello, right, which is only 5 letters. How do you know where the end of the string is? So you have H, E, L, L, and O. Maybe you didn't initialize the rest of the array to something. So they're all holding garbage values. I told you garbage values are random numbers, right? So I can't check is this a garbage value? Like, it might think it's an ASCII value for a character or something. Like, we don't know, right? So there's no, the way that C handles finding the end of a string in a character array is by appending it with this null terminating character, just so that if you have an array of size 50 and you have just 5 letters in it, you know where it ends and you don't have to traverse all 50 things. Does that make sense? Awesome. Next question says, when using the string copy function, which argument has the destination and which is the source? Interesting. Cool. So are you guys familiar with string copy, stir copy? Yeah? Yeah, so we have string copy, and I guess we can write it like this. So where's the destination? Does the destination comes first or second? Are you sure? Where the string is going to go. First, right? So we have DS, I'll just put, that's where the destination is. And then where it's coming from, you might call it the source. So I think what I've written here, if you see this question on an exam, I wouldn't call this the answer. I'm doing this to keep this short and brief. it says which argument has the destination and which has the source, I would write on the exam, the first argument has the destination, the second argument is the source. Don't write this. This is not, I don't think this is answering the question, right? First argument gets the destination, second gets the source. How can we remember this? Just to give you guys a quick way. This is a lot like assignment, right? So if I have A, if I were going to say like A equals some sort of string, there's stuff in here. Do you see that the left side is the destination and the right side is the source? So this is how you can sort of remember, right? It's just like an assignment statement in string copy. The right side gets assigned to the left side. Awesome, so that's a good way you cannot forget. So this one says, does the string length function account for the null terminator? And I guess what that's asking is, if we have this word hello, right? If we're going to look for the string length, what's string length? What is that function? What's the actual identifier for that function? Yeah, what's the name? Yeah, strlen, right? So it's strlen. And then you pass in a string, and it gives you the length of that string, right? So in this instance, if I passed hello, would it give me 1, 2, 3, 4, 5? Or would it account for the null terminator and give me 6? It would give you 5, right? So if you were like a person and you were going to use this string length function, I think I'd be pretty mad if I used a string length function that is in my C library, and I know that my string is 5 letters, and that this will return a length of C. Irritating. This is why we include the null terminator, right? So that it's easy to find the end of the string, and that way inside of strlen, this function, we can easily just find the length of the string. When we see a null terminating character, we will stop incrementing how many things are in this string. Does that make sense? So we will not include the null terminating character. So the answer here is no. Awesome. So true or false? Strcat. What does strcat stand for? Concatenation, yeah. It stands for string concatenation. Does it return the string stir2, stir1? A better way to probably word this is, so if you have a string, you have string 1, and you have string 2, right? So maybe it's cat and dog. So it's asking, will it concatenate the string to be cat dog, or will it be stir2, stir1, will it be dog cat? Cat dog, right? Again, think just like stir copy, it puts it to the left one. So no, it will return, and to keep with the notation that they're using here, I guess I can just write stir1, stir2. Is that okay? Awesome. So what does the string compare function return of 2 strings are lexicographically equivalent? Cool, that's exciting. Do you guys know what lexicographically means? Awesome. So to put it simply, for the most part, we're talking about alphabetical order. But it's not quite alphabetical order because in C, how are characters represented in C? With ASCII values, right? So we use those ASCII values to compare lexicographically, basically. So naturally, A comes before B in the English language, right? So if we're making like a dictionary and we're going to put it in alphabetical order, then A, like the word apple would come lexicographically before the word benign. I don't know why I picked that word, but don't know why I picked that word. So yeah, it would come before benign, right? So because this one starts with A, that one starts with B. I believe, I don't have an ASCII table memorized, but I think capital letters come after lowercase letters in the ASCII table. So a lowercase, if it's a lowercase string, it would come lexicographically before an uppercase string. That may or may not be true based on where it is in the ASCII table. If the uppercase letters come before the lowercase letters, then it's the reverse of what I just said. I don't have an ASCII table memorized, so you could easily Google that. And then just whichever value comes first is what comes first in the ASCII table. So that being said, we're basically talking about alphabetical order, right? Let's assume that we have a string of all lowercase letters. So we want to know what is returned if these 2 strings are equal, right? So if I pass into string compare, oh, first off, what is string compare? What is the identifier, the name of the function? Stir CMP, right? And then you put a string 1 and a string 2. And the question is asking, if these two things are equal, what is returned? Do you guys know? Not quite. Actually, it's an integer value. So if they're equal, it will return a 0. So the next thing is what if they're not equal? We'll amend this question a little bit. Do you guys know what is returned if they're not equal? Yeah, so we're getting closer. So if stir1 comes before stir2, so if it's less than stir2 lexicographically, then it will return a value less than 0, a negative value. If stir1 is greater than stir2, as in it comes after, hello, person looking at me from the window, then we would return a value greater than 0. Does that make sense? Awesome. So do we have any questions on this page? Is it 57? Compares them. It sees if they're equal. And if they're not equal, it will say which one comes first. So like suppose you wanted to take in a bunch of strings, maybe store the strings in an array, right? And you wanted to have some sort of sorting algorithm that is comparing them, right? So I want to be able to have an array that is holding strings in alphabetical order. You might use string compare, right? You might use the string compare function to see which one comes before this. So you might take in, say I take in the word apple, and I take in the word, I won't use benign, let's use Chris, right? I take the word apple, and I take the word Chris, right? I could compare those two things to see which one comes first in alphabetical order, and then put them in the array sorting them in a particular fashion. Does that make sense? Yeah. I'm avoiding writing a lot because I want to make sure that we get through. So if they're equal, it returns 0. If string 1 is less than string 2, then it returns something less than 0. If string 1 is greater than string 2, then it returns something greater than 0. Make sense? So here, if we want, I'll do this. I'm going to not call this stir1. I'm just going to call this s1. So it's equal to 0 if stir1 equals stir2. It's less than 0 if s1 is greater than s2. And then it is, no, not greater. This is less than. And greater than 0 if s1 is greater than s2. So you can remember this, right? If s1 is less than s2, then it's less than. If s1 is greater than s2, then it's greater than. Does that make sense? Any negative number. There's a policy for that. It has to do with, I won't get into that. If you want to know more about the string compare function, I think this is enough for your exam. If you want more information on it, you can Google it. And you can see exactly what is it returning, what value. It's generating a negative number. How is it generating that negative number? It's actually a rather intuitive way to do it. It would make sense. You would probably implement it the same way if you went to try and implement this function yourself. Awesome. Are we good on this page? Awesome. Do you guys expect to have strings on your final exam, like these functions? I know there's a problem in here that uses like every string. Oh wait, is it this one? Yeah, I think it is. So fill in the following function. That's funny. This one says, fill in the following function that is given two strings of equal length and compares them. If they're the same, create a third string that is the result of concatenating the second string with the first, and then print that string. So that's weird, right? So here's what this function will do. It will take in this string 1 and this string 2, right? And what it will do is if these two strings are equal, then create a new string. And what I want you to do with that new string is concatenate string 1 and string 2, put it inside of that new thing, and then print that new thing from that new string. I think it's a roundabout way to print out. It's a little bit of a roundabout way to print out a concatenation of two strings if they're equal. But I think the purpose of this question is to get used to using several string functions. That being said, as I think about this, this is going to require some dynamic memory allocation. And there's a dynamic memory allocation section later in this. So why don't we come back to this question when we talk about dynamic memory allocation. We'll come back to this question and we'll implement this once we've talked about malloc. Is that OK? Awesome. So we'll come back to that question. Don't worry too much about it now. So let's get to this question. Write a program that scans in all of the integers from a file named input.txt, that's important, and outputs their sum. The file is of the following format. The first line contains an integer n, and will be followed by n integers. So the idea here is we take in integers from a file, .txt, and outputs the sum of those integers. That's exciting. So let's go ahead and do that. If I'm going to, this is file I/O. Do you guys anticipate file I/O showing up on your exam? Yeah, so if this is file I/O, if I'm going to use files, what do I need? What do I need to start with? A file pointer, right? So we can use file in all caps. Since it's a file pointer, what's the next thing I need to write? An asterisk, right? And I'll call it input file pointer. Input file, IFP. You guys have probably seen that a lot. You guys know that I can call this anything. I've had a few students who thought that this name was required. I can call this anything I want. I could call it Chantel if I wanted to. It doesn't matter. So I want to open this file, input.txt. So what function should I probably use? fopen, file open, right? So we have fopen. Awesome. So practically, what's going to come in the first argument? The file name, right? It's a little bit of a lie. If it's in the same directory, we can just put the file name. We're going to assume it's in the same directory. If it's not in the same directory, then you would want to put the path towards that file. But yeah, let's assume it's in the same directory, input.txt, and that will be good enough for us. If anybody's using a Mac, if anybody was using a Mac and you were being forced to use code blocks, I know Professor Angel requires that all your stuff run in code blocks. If you were using a Mac and you were using code blocks, even if it was in the same directory, code blocks requires that you provide it the full path. So if you were getting like some weird errors and things weren't working when you were doing file I/O and you were using code blocks on a Mac, that's an issue. That's something that you would have to do in order to make it work. But you can just not use code blocks because code blocks, I don't like it. So yeah, we're going to read things from this file. So what do we need to do for the second thing? R, right? Stands for read. Nice and intuitive. Thank you, C programming. Yes, so that will, do you guys agree that this will open the file and now it will return the address of the file is located to this input file pointer? Perfect. So then I know we're going to have several integers, right? This is definitely not enough space, this bracket down here, that's funny. So I know we're going to have, I'm going to just get rid of this. This is not here, it's a lie. We're going to have several integers. So I know we're going to need some sort of sum, right? So let's put sum. Sum is equal to, what do you suppose we start the sum at? 0, right? So we can start the sum at 0. And then we'll get to the other thing. We'll come up with the declarations as we go. So the first thing I want to do, it says the file's named input.txt. And the first thing it has, the first line contains an integer n, and will be followed by n integers. So the first line in the file tells us how many things after that number are there, right? So for instance, if there were 5 things in this file, the first value would be 5, and then there would be 5 things after it, like 1, 2, 3, 4, 5. And then we would output the sum of those 5 things. So the first thing I have to do is I have to read that first number into something, right? And they call it n, so why don't we go ahead and call it n. I'll put this in our integer declarations up here. So we can do this. If I want to read things from the file, what function do I have to use that you guys have frequently used for file I/O? fscanf, right? If you take input from the user, you would use scanf. Take input from a file, go ahead and use fscanf, file scanf. So we can put fscanf. Awesome. So we'll talk about the first argument. What about this middle argument right here? What goes here? We're going to take in an integer. So what should we put here? %d, perfect. So we have %d. And then what goes in this second thing? Say again? Yeah, where you're storing it. So if I just put n here, am I OK? No, what do I need to put? Ampersand, yes. Perfect. Do you guys agree that this right now looks just like scanf? Right? This syntax looks just like scanf. There's nothing different. Do you guys agree? Yeah. So if you forget how fscanf works, the second half of it looks just like scanf. So what goes in the first thing? Just the file pointer. So if you've ever forgot what are these things, this is literally scanf. You've probably done scanf a million times in your life. And then since it's fscanf, just put the file pointer in the beginning. Make sense? Perfect. So do you guys agree that this will take in the first number and store it inside of n? Good. So now we can use whatever that first number is. So since we're going to be looping, just gave you the answer. Since we're going to be going through all of the file, we're going to have to, I gave you the answer, we're going to have to use some sort of looping structure, right? So we can start with a for loop. We have for I equal to 0, I less than what? Less than n, right? It tells us how many things are in the file, and then I plus plus. So we'll put brackets here for this for loop. So the first thing I want to do is take input from the file and store it somewhere. So I wouldn't want to store it in n, right? Because then that would change the value of n, and that's governing how many times we do this. That wouldn't be good. So I'm going to need something else to store it. So I'll just make some sort of temp variable where we can store like the intermediary things. So here we can do fscanf. The first thing is what? IFP, which is the file pointer. The second thing is, it's going to be an integer, so what is this? %d. And then I made this temp variable so we can just store it at the address of temp. Right? So that will take in the next thing, the ith thing rather, and store it inside of temp. Right? So now we have, say n was 5, the first thing, say the first number was 1. It will store the number 1 inside of temp. Does that make sense? So now that's being stored inside of temp. I want to add all of the numbers together, right? So if I do sum plus equals temp, do you guys see that sum was 0? If the first number was 1, I just added 1 to sum and then stored the result of that addition inside of sum? Do you guys agree that that's what I just did? So do you guys agree that, OK, so suppose my file was, I had 3 things in my file, and the 3 numbers were 1, 2, and 3. So I is 0, I less than n. So 0 is less than 3, right? N was 3. And then we would go in here and we would scan in. The first number would be 1. We would scan that into temp. And then we would do sum plus equals temp. So we have 0 plus 1. All right, good. So if this was the end of our, then we would increment I. I is now 1. Is 1 less than 3? Yes, it is. And then you would scan in the number 2 into temp. And then you would add that to the sum. And you would do that all the way up until the third thing, or the nth, right? And at each point, you're adding it to the sum. So do you guys agree that this will store the sum properly from all of the things in the file? Yeah, so it says, let's see, does it say output? Scans and then outputs their sum. Yes, so then we would want to print the sum after the for loop is done. So we would put something like maybe sum. And then it's an integer, right? We would use %d. And then a \n, why not? Because we like our output to look nice. And then we would just print the sum. Does that make sense? What's up?
Are all the integers we're assuming they're all can be?
Yeah, that could be anything. Yeah.
So I know you put like I less than n. What if like n happens to be like 1 or something?
So first off, remember that the first line contains an integer n, followed by n integers. So the very first thing in the file is storing how many things. We're assuming that it stores how many things after it. So n is just how many numbers are in the file after the very first number, right? So if it's 3, then it's followed by 3 numbers. It will add those. This program will currently add those 3 numbers together and print it to the screen. Does that make sense? So at the very end of this, to avoid a memory leak, I'm not sure if you guys are familiar with this term yet in Intro to C. What do I need to put? I've opened the file, so what should I do? fclose, right? So I would fclose ifp. We'll have a lot more of a. Are you guys? Is anybody here a CS major? So I'm also a CS1 tutor. We'll talk a lot about memory leaks and a lot about more exciting stuff when you guys take CS1, hopefully next semester. So are you guys okay with this function? Not this function. This. Yeah, it's a function. I guess it's a main function. Are you guys okay with this? Awesome. So let's move on. Page 8. Perfect. Next thing, pointers. Do you guys think pointers were like one of the hardest topics in Intro to C? I personally, I've taught Intro to C for a while. I've personally found that pointers are generally, I think, the topic that Intro to C students struggle with the most. So yeah, being said, let's make sure we understand pointers. So let's check out this what's wrong with the following lines of code? We have int x equals 15. I think we're good there, right? Seems fine. Then we have int star p equals address of x. What about this line? Is this okay?
So that just means like we declare p as a pointer and it's pointing to the address of x, which contains 15 or no?
No, it doesn't contain 15. Well, yeah, so let's do this. So over here, we have two variables, right? We have int x and int p. So here we have x, it's an integer, and it has some sort of memory address, right? So like 0x118. So can you guys see that okay? So like 0x118, I made that up, right? And then we put 15 in its sort of little memory box, right? And over here we have an integer, we call it p. It's not an integer, it's an integer pointer, which, in case was not made clear to you, these two things are different types. The same way a char and a double are different types, an integer and an integer star, an integer address, or an integer pointer is a different type, fundamentally. And does this also get an address? Yes, it does, right? So 0xEFF, I made that up. Perfect. So on this line, what gets stored inside of this box?
The address of that.
Yes, so that's just 0x118, right? So first thing, the address of x. Do you guys agree that that's an address of an integer? And without looking at this p, do you see int star? Anything int star, do you guys agree that will store the address of an integer? Right? That's what a pointer does. A pointer is a variable that stores the address of another variable. And an integer pointer is a variable that stores the address of an integer, right? And really quick, do you guys agree that these two things don't look the same? And therefore, it's probably not the same type? Yeah, so it's not the same type. A little more reinforcement that an integer pointer and an integer, although they both have the word integer in them, they are not the same type at all. Awesome. So do you guys agree that this is an integer address and on the left side is also an integer address? So those types match. If this ampersand wasn't here, would these types match? No, they wouldn't. And that would not be good. That would produce some pretty unexpected output. So then we do star p. What does the star do? It dereferences p, right? So the star says, it takes a memory address, like p is holding this memory address 0x118, and it says go to that memory address. So that memory address is right here, and refer to the data that's there. Currently the number 15 is there, but we assign the number 9 to this memory address, right? The box where this memory address is. So we basically go over here to x, and we change that to a 9. Does that make sense? Do you guys all understand how that works? It's called the dereference operator. We stop referencing x or this address that p holds, and we actually go to where it's located and refer to the data that's stored in that segment of memory. Perfect. So then we printf %d and p. So first off, we haven't seen some errors so far, right? There hasn't been any errors yet. So that tells me by process of elimination that there has to be an error some point on this printf line. Do you guys see it? Yeah. So check this out. %d, what does a %d expect? It expects an integer. Is p by itself, if I put p by itself like this, what's it referring to? Is it referring to an integer? No. In this little diagram I have up here, it's actually referring to this address. Do you guys agree that this is not an integer? So this is %d, it expects an integer, and you're passing it an integer address. So if I wanted to actually get an integer out of this, what could I do? That would give us an address, right? I want to get the integer, 9. The asterisk is what we're looking for. I want to dereference p, right? So this way, I would go to 0x118, which is right here, and refer to the data that's there. Well, the data that's there is an integer, right? And do you guys agree that now you have %d and then star p would print out the integer 9 currently, and that would fix it? So another way that we can make this code correct is what you said in the beginning, mentioning the conversion specifier, or conversion code format specifier, whatever you call it. There's a bunch of names for it. So this is %d. We changed p to be an integer. Another thing we can do is change this format specifier to expect an address. Do you guys know the conversion specifier to expect an address? Percent what? P, right? What do you think the P stands for? Pointer. So that's a way that you can remember it. So %P will print out a memory address of where something is located. If I had my laptop open, I'd show that to you. But thank you, projector, for not working. All I've wanted, like in my SARC sessions, is a projector. I'm like, finally at study union, I get a projector so I can type it and then have it show up on a screen so everybody can see it. And then now my computer doesn't show up on. I'm very upset by this. This is ruining my life. Awesome. Here's a question. So this is a really, really good pointer question. During this question, I actually pulled from one of my CS1 exam reviews. Their exam 1 from this semester, I used this question on their exam review way, way earlier in the semester. And I put it here because you guys learned about pointers too, so this is a good question. And I think this question is really interesting and could be moderately difficult. So let's check this out. It says fill in the blanks with the proper data types that each variable should have. That's interesting. So basically the idea is we have all of these assignment statements, right? And I want to, based on these assignment statements, deduce what these types should be. So let's go ahead and do that. We have R equals the address of C. We don't know what type, but since you guys agree that R needs to be some sort of pointer. So then we have A equals R. All that really tells me is that A and R need to be the same type. Not sure yet. And then we have star R equals 17. Well, wait a minute. In the beginning, we set the address of C equal to R. Tells me it's a pointer. Now we dereference R and assign a thing of what type to it? An integer. So presumably this could be an integer pointer. Do you guys agree? Because we dereference R and then assign an integer to it. So you could argue that R is an integer pointer. So that would be the first one. So now, since we know that R is an integer pointer, remember at the very beginning, we assigned the address of C to R. So if R is an integer pointer and it's pointing to C, what does C have to be? An integer, right? Like a regular old integer. So it's just an int. Perfect. So now we do star H equals A. Well, we missed something. We have A equals R. We now know what the type of R is. What does that mean the type of A also has to be? An integer pointer, right? Because the right and the left side must be the same type. So A is also an integer pointer. That's great. So then we have star H equals A. Well, A is an integer pointer. So we dereference H, and we give it an integer pointer. So if we dereference H, and we put an integer pointer there, what does that mean when H wasn't dereferenced? What was the type? So you might think initially it's an integer pointer. But if H was an integer pointer, when we dereferenced H, would we not put an integer there? And do you see we did not put an integer here? We put A is of type integer pointer. We have put an integer pointer here. Hello. Do you guys agree? So it's not quite an integer pointer. It's not pointing to an integer. It's pointing to an integer pointer. Meaning it's what? A double pointer. Perfect. So H is actually a double pointer. Does that make sense? Do you guys all follow that? So then we have %A is equal to 99. So we dereference A and put an integer there. Well, we already found out what A is, so we know that A has to be an integer. Hello. Do you know where this packet is by chance? Do you have this packet? OK, cool. If you don't have it, I am solving it up here. If you did have it like on you, you could write notes on it, but I don't think it would be too detrimental, like not helpful for you if you didn't have it. Awesome, perfect. So then we do I is equal to the address of H. So this is interesting. H is an integer double pointer. So what is the type of the address of H? It's the address of an address of an address. So what is this? A triple pointer. Perfect. New person in the room gave me the answer. Yeah, it's a triple pointer. Does that make sense? And that's because we have the address of H here, and H is a double pointer, so this is an address of a double pointer. The address of a double pointer is a triple pointer. I really like this question. I used this for my, my CS1 exam 1 review. It was really cool. Awesome. Are we OK on this, how we sort of logicked our way through this? What's up? Ooh, that's a great question. So first off, I would say they're not very common. I haven't used a lot of triple pointers in my life. I've programmed a lot in my life. I programmed in C a lot in my life. I don't use triple pointers often. I have used them. I would say for now, as you guys are in Intro to C, the most important thing, know that they exist. Start to write much more complicated programs. You might come to a point when a triple pointer might be useful. We'll continue on for now. Maybe Google that question. When would a triple pointer be useful? But you can have pointers to pointers to pointers to pointers to pointers. You can have like a 5-dimensional pointer. It exists. Why you would use a 5-dimensional pointer, I don't think I've ever seen so many levels of abstraction of memory addresses, but it exists. You could do it. When you write more programs, I think you guys will see maybe at some point you might use them. I think 2-dimensional pointers are extremely common. You will see those a lot. 3-dimensional, not so much. 4-dimensional, I don't think I've ever really seen one used, but it exists theoretically. Awesome. So how would you, so 22. How would we set the element? Are you guys okay with this question, by the way? Perfect. So we set the element, position 3 of an array, called array, to be equal to 7 using pointer notation. Interesting. So by pointer notation, Matt wrote this question. I believe he means pointer arithmetic. Yes, so using pointer arithmetic. Did you guys cover pointer arithmetic in Intro to C? Yeah, so I don't think this is entirely important for you guys, so I won't belabor this point too much. There is some there's an important fact in here, but I'll just sort of let you guys know. I'll give you guys the answer. So first off, if A is an array, suppose A is an array. If I put A by itself, do you guys know what it's referring to? So here's my question. Is it referring to the value at the first index, or is it referring to the address of the first index? It's referring to the address of the first index, meaning it's the base address of the array. Array that looks like this. Maybe it's an integer array, and maybe the number A sub 0, this refers to 2, right? However, there's a memory address here, right? 0x118. A by itself, this is referring to the address of A, the base address of the array. Does that make sense? So there's this neat trick in C called pointer arithmetic. So this might seem weird. What if I add 1 to A? Yeah, so I'm adding 1 to a memory address, which should seem weird, right? And here's the idea. Do you guys know how many bits are in an integer? So there are 32 bits in an integer. Do you guys know how many bytes are in an integer? 4, right? How many bits are in a byte? Ooh. 8. There's 8 bits in a byte. So if there are 8 bits in a byte and there are 32 bits in an integer, how many bytes are in an integer? 32 divided by 8 equals 4. That's where you're probably pulling that number 4 somewhere from like your mental architecture. You heard it somewhere. Yeah, there's 4 bytes in an integer. You say there's 32 bits in an integer. It means the same exact thing. But yes, that being said, memory are stored using bytes. So if I add 1, if this is an integer array, if I add 1, let's suppose this was at 0x110. If I add 1, this next thing, if it's an integer, is not at 0x110. It's 4 bytes ahead. So this will be 0x114. Does that make sense? And what pointer arithmetic does, when you add 1 to A, it assumes basically by the type, you don't need add 1 to 0x111. That's like the middle of this integer 2, how we're representing this integer 2. It doesn't do that. So what it'll actually do is move it forward 4 bytes. And in an array context, when it moves it forward 4 bytes, it will give us this second value, say it was 3. It will give us this second address. So this gives us this address right here. So say A and then put a 1 here. Do you guys agree that that's the value stored at 1? This is not, do you guys agree that this currently is not the value stored at 1, this A plus 1? This is the address of where this index 1, do you guys agree? So if I want to get the value at an address, what do I have to do? I have to dereference that address, right? So now A plus 1, in this case, would give me 0x114. If I dereference 0x114, then I get the value 3. So these two things are the same. And that should tell you more about what this notation does. When you do array brackets 1, what that actually says is move forward 1 spaces from this address that A is, and then dereference that address. So the answer to this question, it said, how would we set the element at position 3 of an array called array to be equal to length 7? So if it's called array, this is the actual answer to the question. We want to go to position 3, right? So normally you could write something like position 3 equals 7. But if we follow this idea over here, we can do array plus 3, and then dereference that address and set that equal to 7. And these mean the exact same thing, which should maybe clarify a little bit more to you that an array is a pointer. It's exactly a pointer and nothing different than a pointer. It's a pointer to the base address of an array. Does that make sense? And this right here is what this notation does behind the scenes. This is just basically a shorthand. Does that make sense? What this does is says move three spaces forward in the array and then dereference it, which this says move 3 spaces forward in the array and then dereference it. That's what's going on here. So this is important. I don't know if pointer arithmetic. I feel maybe in Jahani's class, I've heard they're doing some pretty hard stuff. Maybe in Jahani's class they're doing pointer arithmetic. Is anybody in Jahani's class? Anyone? No? All right, yeah. I heard that class really. It's Intro to C. Yeah, it's an Intro to C course. But I don't know if you guys have covered this quite in your Intro to C course. But maybe it has the potential to show up on an exam. I think the most important thing that you should grab from here is that an array is a pointer. I think that's what's most important for you guys. An array is a pointer. It's nothing more than a pointer. It's exactly a pointer to something. An array holds the base address of an array. Perfect. Are we good on this page? Pass by reference functions. That's exciting. So what does this say? This says fill in the following function that is given two parameters and then swaps their values. Fantastic. All right. Do you guys see that we have an integer address and another integer address? Do you guys see that? So if I want to swap their values, first off, would it be possible if there were not asterisks here, right? If these were not pointers, would it be suppose I called this function from main, and I passed in the value a and b, and a was holding 5 and b was holding 6. If I swapped them in this function and they weren't, suppose I successfully swapped them from within the function, if I didn't use memory addresses like this, didn't use pointers, would that change the values back in? No, they would not, because we passed them by value, right? Here we're passing x and y. We're passing references to this function. Does that make sense? We're passing addresses, and that gives us, using a special operator we've talked about, a special way that we can maybe dereference those addresses, go to those addresses back in where they're actually stored in memory, and mess with the data that's there from within this function. That way, back in main, they're to what they were from whatever they were in this function. So before we talk about that, how do we swap two numbers together? So you might say, well, why don't we just do a equals b and then b equals a, right? You guys see why that wouldn't work? So say a was 5 and b was 6. So you say a equals b, so now a is 6, and b equals a. But a is now 6, right? So now both of them are 6. So instead, store the current value of a. So say something like, we can write it. You would say, because we'll get to the pointer or notation, you would say maybe temp equals a. So now that's holding what the value of a was. And then a equals b. So now a is no longer holding that initial value. And now b equals temp. And now temp is holding the original value of a, and that would swap the two things. So let's go ahead and do that. We have int temp equals, and this is x, right? So will this, is that OK? This is x by itself, and x is a memory address, right? So do you guys agree that this is an address of an integer, and this is an integer? Yes. So if I put the asterisk here, do you guys agree that I dereference x and now refer to the data that's there? That's the number that's there. So I get the number, say it was 5, like we've been doing, and I store the number 5 now in temp. This is now no longer a memory address. This is an integer, the right side. Does that make sense? So yeah, you would dereference x in order to get that value. Awesome. So now, again, you're pretty much going to be dereferencing them for the rest of the time, right? Because I want to be able to actually dereference them, go to in memory, and change the data that's there. So now we said, now I can store the value of y into x, right? Because now I've stored the previous value of x. So I could say star x now equals star y. Does that make sense? So now x holds the value that was stored at y. Are we okay? Are we okay so far? This dereferences y, gives us the integer that's there, and stores it at the memory address where x is. Is that okay? Fantastic. So then finally, I want to put the original value of x into y. So what's on the right side of this equals? Temp, yeah. That's the original value of x, right? And that would swap two integers together. Are you guys okay on this? Is it 32? Got to keep going. How many pages we got? I think there's 13 pages in this thing. Yeah, cool. Perfect. So use the function from the previous question so that the values of a and b are swapped. So this is a function call question. It's just asking, how are we going to call this function? So first thing, if we're going to call the function, what's the first thing we need to call the function? The name of the function, right? That's the easy part. So we have swap. And then you guys see that we pass two things here? So we pass two things. What are we going to pass? Am I going to pass a and b? So what's the type of a? An integer. What am I supposed to pass? An integer pointer, an integer address. So I don't want to pass a. What do I want to pass? The address of a. And similarly, the address of b. Does that make sense? You guys following me so far?
If it was an array, would you have to put that in the ampersand?
So,
You're trying to pass an array.
so first things first, this won't swap the way that this stands right now, int x could be an array, and maybe int y could also be an array. These are pointers. This, if you're asking me a question like on how would we swap like two indices of an array, like suppose we have an array with 1, 2, 3. Suppose I wanted to swap index 0 and index 2, right? So swap the 1 and the 3. This function will not do that. But I think I know what your question is referring to. What if we had an integer star a and an integer, I'll do this, and an integer star b, right? And suppose somewhere in the code they had numbers associated with them. So like some way I can dereference a and refer to an integer. So suppose it's pointing to an integer that exists, and suppose that b is also pointing to an integer that exists. So if I call swap, so suppose there's code here, and then a is now pointing to an integer, and b is now pointing to another integer. In this case, if I wanted to swap the two things at these memory addresses, so do you guys agree that this is a memory address? So I would just pass a. And do you guys agree that this is also a memory address? I would just pass b. So I wouldn't need hands because these are memory addresses. Does that make sense? That's assuming that these dots that I've put, we've initialized a and b to point at some integers. Does that make sense?
But if they aren't pointers,
Then, yeah. Because, see, this is an integer pointer, and then this is an integer pointer. So by just passing a, we'd be filling out our contract. What if I put the ampersand of a? This is no longer an integer pointer anymore. What is it now? The address of an integer pointer, which is what type? Not quite. This is not an address of an integer. It's the address of an integer. Meaning it's not an integer pointer, it's an integer pointer. It's a double pointer to an integer. Ampersand a is a double pointer to an integer. This expects a pointer to an integer, so these types no longer match. So it would be like wrong to put an ampersand here. Does that make sense? Awesome. Are we okay there?
Going back to the first one,
Yeah.
to match it, since it's the function has an integer to point at,
Yeah.
to match it, put in a...
Yeah, so this is our function declaration, our function definition. This is essentially a contract, right? So this void, it's a contract that says you will return nothing from this function. I cannot return the number 15 from this function or return a character from this function, I cannot return from this function. I can have a return statement. I can put return and then a semicolon. Is that required? No, but you can do that. So a return statement is not required, but I cannot return a value. Similarly, this is also a contract. This says, I don't care what you pass, as long as it's an integer pointer, as long as it's an integer address. It could be any integer address. It could be, I don't care how you do it. You could pass an actual integer pointer. You can pass the address of an integer. I don't care what it is. You just have to pass an integer address here. And the same thing with the y. If I tried to pass an integer here, like this, right, using this a, this is an integer, I have now broken the contract that I made up here, right? This expects an integer address. I have now passed an integer to it. So I do need an ampersand. Do you guys like my ampersands, by the way? Worked a lot on those, right? Because I'm supposed to like draw them whenever we do like this pencil code. So for a long time, I just did this. If you find like a lot of old CS notebooks, you'll see like scribbles like this, and it's me trying to draw an ampersand until eventually I succeeded. So I take great pride in the quality of my ampersands. Yeah, what is that thing? Yeah, that thing, right? Yeah. Eventually, you'll be writing a lot of code in your life here at UCF, and also in your technical interviews, you'll probably do it on a whiteboard. So I would get good at drawing all of the shapes that you have to draw in programming. Awesome. So let's keep barreling. Now, again, we have what is the output of the following program. So this one has a function called foo, and this one is main. So what's important about this is, again, we're passing addresses. So anything, we have all of these dereferences, anything that changes with these values in here will actually change it at a memory level. So you guys know if we passed it by value, if we passed a and b by value, anything that happens inside of this function would not change what's going back on in main. However, since we pass these things by reference, it will go to those addresses and mess with all the data that's there and change it back in main. So let's figure out, we have, down here we have x, y, and we have z. Can you guys see that? No? All right, are we good? Perfect. So we have x, y, and z. X is 12, y is 4, z is 3. So then we do this foo, and we pass the address of x and the address of z, right? And once we hit this function, we transfer the control to this function. Does that make sense? So now we're here. We don't worry about anything going on in main yet. Now, we cannot do any code in main until we finish this function, right? So now we pass in the address of x. So this is currently holding the address of x. And this is currently holding the address of z. And recall that z and x, we have this value and this value right here. So we have 12 and 3. So in here we say star a, which is currently holding x, which is 12. So I'll even put like 12 here and 3 here, just to make this explicit. We have star a equals 2 plus star a. Well, star a, that dereferences a, and that's the address of x. So if we dereference the address of x, we get the value at x, which is 12. So this right here, star a is equal to 12. If the star wasn't there, do you guys agree that that would be a memory address, and we'd be subtracting something from a memory address? That's not what we want to do. That would be pointer arithmetic, actually. Perfect. So then we have star b, right? Star b says go to whatever is at b. Well, b is holding the address of z. And if we dereference the address of z, we get the value at z, which is 3. So this is equal to 3. And this is 2 plus 12, which is 14, minus 3 is 11. So on the left side, and we'll even put this, I'll put star a, star b. On the left side, we have star a, right? So we're going to go to that memory address and put this value on the right side there. So star a is now 11. And recall, we'll get back to this later, recall that star a, since we dereferenced a and that held the address of x, that the value of x actually just changed. We'll get to that. When we're done with this function, we'll make sure that whatever a, the last value of a is in this function, and whatever the last value of b is in this function gets changed back over here in main. So let's continue. Then we have star b and star a. Star b, remember star b is currently holding the number 3. So star b is equal to 3. And star a now is equal to 11. It was equal to 12, now it's equal to 11. So this is 3 plus 11, which is 14, and it stores that at the memory address that B is pointing to. So we go to that box in memory, and we put the number 14 there, right? Oh, look, and then we hit a print statement. So let's see what the first line that we print is. The first line, I'll put it down here. Can you guys see that? Yeah. I'll put it down here. We say A equals %D, B equals %D, and then we dereference these two things. Well, these are those values, right? So we have 11 and 14. Do you guys agree? Are we okay so far? Awesome. And then we return. We see this weird return statement. Return 2 plus star B. Well, star B currently is 14. So that's 2 plus 14, which is equal to what? 16. So this will be equal to 16. So when we return here back on this line, we're now back at foo, this line right here at the function call. This returns the number 16. Do you guys agree? So now we set the value of y equal to 16. Also, mind you, star A, that is, when we were messing with star A, we were messing with the data at the address of x. So the address of x and star A are actually the same thing. X changed in that function. Similarly, star B held the address of z. So we were dereferencing B. We were actually talking about z back in main. And now the last value that this was when we left the function was 14. So z is now 14. So that being said, if we look at the last values here, you guys see we hit this printf statement now? So the second line of output says x equals, and then we have x. Well, the last value that x was 11. And then y equals, and then y. The last value that y was 16. And then z equals, and then we look at z, and the last value that z was 14. So we have these two lines of output. Is that okay? How do you guys feel about that? Again, this is a lot like, remember the for loop we talked at the beginning? This is a lot of, it's potentially one question on your exam. I could see this on a free response question, though. It's potentially one question on your exam. Maybe when you see this, you know that this takes a long time to do. Maybe skip on to the other parts of your exam and complete those things first, and then come back to a question like this. Does that make sense? Perfect. So are you guys okay with this page? Awesome. Let's keep barreling through. We have several pages left. Structs. Cool. So let's do this. This says, what are the differences between the malloc function and the calloc function? All right, first things first. What does malloc and calloc do? They allocate memory dynamically, right? How much time do we have? 15 minutes. Cool. I would like to pose a stop right here for a second and give you guys sort of an option. So we have about 15 minutes left. There are a few pages left. Would you guys like to? I can do two things, one of two things. I can sort of open the floor for questions, or we can continue barreling through the rest of this packet. What would you guys rather do? Continue? You guys want to continue going through? At any point, would you like to sort of stop, like maybe at the last 5 minutes or something like that? You guys can have. Do you guys have a few questions sitting in your brain, or are you guys okay just sitting back and watching the show? Maybe like the last 5 minutes. You guys have any lingering questions? You guys can just. This is the last time. This is like my session, which is kind of like, this is my last session. My last intro to CE study union was yesterday, so this is my last SARC session for the semester. So yeah, like at your last sort of like time to ask me questions, you guys can just some rapid fire. Do my best to give you guys the most conclusive answers that I can give you. Awesome. So that being said, we can look at this. Let's make a decision just so that we can get to the things that you guys want to get to the most. We have dynamic memory allocation, we have structs, and we have linked lists. What do you guys want to see the most out of those three things so that we can prioritize what we do?
I said linked lists.
So linked lists involves structs. So maybe if we talk about linked lists, it involves a struct, so we could do it that way? Yeah. Do you think that would be fair? Awesome. And linked lists potentially also include dynamic memory allocation, depending on. So yeah, linked lists could potentially encapsulate all of this. So yes, we will do linked lists. Linked lists are here. Fantastic. It's interesting that it got printed on the back of this page when no other back was printed anywhere. That's very weird. Awesome. So we have linked lists. What are the advantages and disadvantages of linked lists compared to arrays? Have you guys been told this in your class? So I'll just enumerate these one time. First off, arrays are contiguous in memory. Do you guys know what that means? In memory, right, they're right next to each other. So like what we showed before, right, if we're at 0x110, and this is an integer array, the next address is literally right next to it. 0x114, and then the next address is 4 bytes ahead of that. 0. This is not the same way. In a linked list, they could be in memory. So you can have like 0x118, and then 0xFE7, and then 0xABC. They could be anywhere and spread throughout memory, which you might argue is an advantage, right? Because what if you have a continuous block of memory sitting inside of your memory? So that's an advantage. Here's a disadvantage. So in arrays, you have order 1 access. You have really fast access to an arbitrary index, right? I can just say array bracket 5, and I immediately go to index 5 and have access to that element, right, in just really quick, fast time. For linked lists, that's not true. I only hold a reference to the very first element. So if I want the 5th element in the linked list, I have to start at the first element and traverse to the 5th element in the linked list, right? So I don't have really fast access to just any arbitrary node in a linked list, whereas arrays I do. So yes, those are a few things. There are other advantages and disadvantages. I think those are okay for now. You guys are probably more interested in this question. Not this question. Where's that? Is it even written? Yeah, there it is. Perfect. Now my pages are out of order because we skipped around. Perfect. So let's check this out. This involves a struct and a linked list. So given the following struct for a linked list node, write a function that prints the contents of a linked list given a pointer and the head of a list. Awesome. So, yeah, so if we had my laptop, which is what I wanted, what I would have liked to done is like actually show you like the printing of a linked list. But since I don't have my laptop and I can't code all of that up for you, we're running low on time. So let's just code this up. So this is a typical linked list node. Have you guys all seen this before? This linked list node? Not very often. Are you, in all of your classes, are you guys all covering linked lists in your class? That's great, by the way. Okay, this week?
Yeah.
So did you start it this?
It's not really on exam, but she did as part of the exam review want to know what it is, but it's not on.
Okay. Okay. Professor Angel?
Yeah.
Cool. I love her. Awesome. So we have a struct node. So this is our typical struct node. It's a struct, so it tells us a little things about structs. It has an integer data, right? We could put any kind of data. It could be a character. It could be a string. So here we have this struct node star next, right? And this is weird, right? Because we have the struct itself inside of the struct. But it's not quite the full struct, is it? This is a pointer to a struct, meaning it doesn't look like the struct. It just holds the address of a struct. Does that make sense? So that being said, are you guys aware of sort of this pictorial representation of what a linked list looks like? This is a very undetailed picture, in my opinion, of like a linked list. 5, 13, and 11. In my session, I zoomed in on these nodes and made a much more detailed version of this diagram. But I don't think we have time for that. What's up?
Quick question.
Yes.
Since this one only has one integer data, like just one thing, if they had like integer data and let's say char some a or something.
Interesting.
Okay, so with a boxer, will it be 2 boxer or be just the same thing inside that one box? Be like a 5/.
So if you were storing both, this is interesting. I think this is an interesting question. If you were storing both integers and a character in the same box, if I were drawing the box, first off, if I have a much more detailed version of the way that I would draw the box. In this very elementary version that I have right here, I would probably just draw it as like 5, and then maybe a line, C, and then like an arrow, and then like 13 and like A, and I'd probably put single quotes. However, there's a much more detailed way that I could elicit how these things are actually represented in memory. We won't worry about that for now because we got to barrel through. Awesome. So for printing a list, the idea is we're assuming that our linked list is initialized as it is up there. Times it. 51, perfect. We're assuming that it is initialized as it is up there. So the idea is, we're going to do this very quickly. We want some sort of temp pointer. I want to iterate through this linked list, right? And when I'm at the first element, I want to print the integer data, right? So access the data member. This is about structs. And then somehow, I want to get to the next element, right? And then now that I'm at this next element, I want to print the data at this next element. And then I'm going to get to the next element. And now that I'm at this element, I'm going to print the data at this element. And now suppose the next element is null. That's how we'll know when to stop. So you do a repetitive check, repetitive, sounds like a loop to me. You do a repetitive check over and over again, see whether or not the next thing is null. And I would argue maybe not even the next thing. Now we move the temp forward one more time, check, am I null now? Don't try to print anything if it's null, so we'll stop here, right? So that's how we'll sort of stop. So let's go through, I want to make sure we get all of the code. It's a good amount of code. So I want to make sure we do it. And then we have about 3 minutes to do this, and then we can open the floor for just open questions. You guys can ask anything. So I'll go through this rather quickly. So we'll start with a node. This is the node that's going to increment through our linked list. So we'll start the node at null. It's a good practice to initialize your pointers to null. If you haven't talked about that, when you get to CS1, you will talk about that at length with me. You guys will see me again. So first things first, what if the head is equal to null, right? If the head is equal to null, we might want to print something like, hey, this list is empty, right? Don't try and print a linked list if the head is null. You could potentially end up in a segmentation fault situation. If you guys don't know what that is, it'll break your program. So if the head is null, what we'll do is we check, is head equal to null, right? This is like asking the question. If it is, then we'll do something. We'll just printf something like empty list. And then we'll put a new line, and then we will return. Awesome. So we'll close these brackets. And then next thing that we would like to do is we would like to iterate through all of these. So I'm going to do this in a for loop. Since I'm doing a for loop, it's going to look a lot different because we're not using like an integer index anymore, right? We're going to use this temp pointer. So what we're going to do is we're going to start temp at the head. So temp is now holding the address the address that head is. We're going to check over and over again. Remember before when we were doing the traversal, we went, we printed, we went, we printed, and then when we hit null, now we stop the loop, right? So we want to continue looping while the temp is non-null, so not equal to null. That's a way that you can check that. Also, in order to get to the next thing in our linked list, we need some sort of increment statement here, right? So I want temp to be equal to the next thing. So in order to do that, I'll just tell you guys because we're running low on time. Not quite. We can't just do like temp plus plus, right? That will add 1. Temp is holding a memory address. That's not what we can do, right? So what we need to do, we see that the linked list has a next pointer. And since it has a next pointer, the next pointer is holding the address of the next thing, right? So if I go over here and put temp arrow next, I put the arrow because I have to dereference temp. I want to dereference temp and access the next field. That's the address of the next thing in memory. But it's not good enough to just put this. This just sort of states. This is like putting I plus 1. Do you agree that I have not assigned anything here? So I have to assign this to temp. Does that make sense? So I store the address of the next thing in temp. Now temp holds the address of the next thing. And now I can dereference this address and print the data member. Make sense? So what we can do is, I'll put brackets here, get rid of this garbage. I can put print f, and I want to print the integer data, right? %d. And then to print the data at temp, what am I going to do? Temp, is it going to be an arrow or a dot?
Arrow.
An arrow, right? And then data. So this will print the data at temp. The next thing that you might want to do is you might want to optionally print a new line or a space. So if we're on the very last thing in the linked list, you guys suppose we'd want to print a new line, right? And if we're on not the last thing, maybe we print a space so that the output doesn't look like a jumbled mess. So you could say something like if. How do we know if we're on the very last thing in the array? So if I'm over here, and I know that the next field of temp points to null, do you guys agree that I'm on the last element? So after this element, print a new line, right? So you can do a check like this. You can say if temp next is equal to null, then print just a single new line. Does that make sense? Similarly, otherwise, if we're not on the last thing, I just want to print a space every time. So like print the number 15 and then a space, and then print number 11 and then a space. So else printf, if you guys don't know how to print spaces, literally hit the space bar right here, that's a space, semicolon, and that will print a space. Put it up. Awesome. And now if we close this, assuming we have a linked list that is initialized properly, this will print all of the values in a linked list. Awesome. It is now 10:57. What I would like to do is just open up the floor for just any questions that you guys might have. Else will print a space. So this says, this is like in pseudocode, this is asking the question, are we on the last element? Then print a new line. Are we not on the last element, right? Otherwise, if you're not on the last element, there's two options. You're on the last element or you're not, right? So if we're not on the last element, put a space between these two things. If you don't understand this logic, I think the most important thing is here and here in regards to linked lists. Does that make sense? Awesome. Any other questions? We got 2 minutes. Any random questions? Maybe about structs or pointers? What's up?
So what if, how do we define the string if we don't, if not supposed to use strlen?
So it depends. Are you being asked to code up strlen? Because how are you supposed to find the length of the string without using the function strlen? My answer to that would be write a string length. So a function that finds the length of a string when you pass in a string, which is longer than a minute, so I couldn't like code all of that up in pencil. Not being able to type really slowed me down. What's up?
On yours, when you know star temp,
Yeah.
because I know on mine, like I see our professor does it where you put struct node and then star.
Oh, yes, yes.
But that's because you did the type def?
Yes, it's because I did typedef. Typedef gives an alias to this whole data type here. This whole thing is a data type. Typedef, if I did typedef and then maybe put int,
Yeah.
and then I called it hello. What this does is it gives an alias to the data type int. So now later in the code, right, ... later in the code I could put something like hello and call it like a, and a is an integer. I just gave an alias for the data type integer. And then this is the same exact thing. You have typedef. This whole thing, struct node, int data, blah, 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 that's all one single data type, and then you give this alias node to it.
If it's the same name, like struct.
Even if it's the same name. And it's common practice with structs. Like I usually give it the same name as the struct. So that way you don't have to type struct node. Do you guys see that we had the type struct node here?
Yeah.
That's because the alias has not been defined yet on this line. Do you guys agree? So it doesn't know, I couldn't just put node by itself. So inside of the struct, I still have to put struct node.
And when you have that struct node pointer next, it's essentially pointing to another structure with the same stuff in it.
Yes.
Int data,
Yeah.
but it's empty for now.
Yes, exactly. What's empty for now? Your question?
The pointer next is pointing to another node.
This, yes. So this holds the address of something that looks just like this. And we're assuming, since we're printing something that's pointed to by this head, we're assuming that it exists, right? We're assuming that there's a linked list that's initialized properly and it ends with null and it looks sort of like the picture up here.
Yeah.
Does that make sense?
Yeah.
We're assuming that this exists. We start here, we print this thing. We go to this, we print this thing, and so on. Awesome. So it is now 11, which is, my session is now over. 9, 10, 11. Yeah, my session is now over. Awesome. I hope this was this helpful for you guys? Do you feel like we tried to make this as comprehensive as possible, lots of code tracing. There was some fill-in-the-blank stuff. I tried to get a lot of feedback from a lot of the students from the session. So yes, I'm sorry about the technical difficulties. We could not get my laptop running. I think this would have we could have got through a lot more stuff if we were able to use copy and paste and not have me writing things with pencil up here. But it is all good. Awesome. So I know you guys have probably worked really hard this semester, right? Programming is really hard. Are you guys, who's a CS major? CS, what are you guys? Computer engineering?
But
Oh, cool. So yeah, so you're all going to be coding in your. So if you haven't fallen in love with the subject yet, I think most people fall in love with the subject. Like most people are like, yeah, CS is awesome, right? So awesome, such an awesome subject. If you haven't fallen in love with the subject quite yet, I think by CS you'll really fall in love with the subject. That's when it gets fun. But yeah, I know you guys have probably worked very hard this semester, like staying up late, coding up like solutions to really. If you class, you did a lot of things about pirates this semester. Yeah, is that due today? Yeah. So coding is hard, right? After a long time, when you do it a lot, it gets easier. I hope you guys have really enjoyed this semester, and I think you guys are going to. You guys are obviously very proactive. You woke up at like 9 in the morning to attend an Intro to C review session. So obviously you guys are studying hard. You guys care about what you're doing. So yeah, good luck on your final. I hope to see all of you guys again in CS1 next semester. I teach that too, so I hope you guys all come to my sessions then. And tell all of your friends to also come to my sessions. But yeah, definitely good luck. And do really well on your final. Go get A's. Study hard until your thing. Thank you guys all for coming. This was really fun. I like doing this. So yeah, you're welcome, guys. Definitely, if you guys go to CS1, I will most likely be